In this example, we're going to find the cross product of two vectors and then verify that that cross product is orthogonal to both of the original vectors. The two vectors that I've decided to use are to pay an homage to both Wayne as well as Macomb County. Vector U is going to be 586 and vector V is going to be 313. So we're going to find out what happens when Macomb crosses with Wayne. I don't know. That's I'm slowly losing my mind. Don't worry about me. I'm going to be fine. So what I'm going to do is set up the cross products the same way that I set up the cross product in our last video. I'm going to put the three components of U across the second column here with I, J, and K across the top. For V, we'll have that in the third row. Now again, evaluating this determinant, I'm going to recopy the first two columns, I, J, 5, 8, and 3, 1. Then, go and give it a little slashy. Hope you don't mind. So we'll go downward direction first. We have 8 times 3 for the I component, so 24I. 3 times 6 for the J component. And 1 times 5 for the K component. Then, in the opposite direction, a little slashy. We have 3 times 8 for the K component, that'll be 24K. That's a lot of money. Then we'll have 1 times 6 for the I component, that'll be 6I. And 3 times 5 for the J component, that'll be 15J. Now, after I do that, I am going to combine all of the components that I see together. For the I component, I see that we have 24 minus 6 of those, that'll be 18. For the J component, I see 18 minus 15, that'll be 3. And for the K component, I see 15 minus 24, that'll be negative 19. So this is the cross product of U and V. Now, what I'm going to do is verify that this is orthogonal to both of the original vectors by taking the dot product of this with both of the original vectors. So take 18, 3, negative 19. We're going to dot this with the vector 586. So that'll be 18 times 5 plus 3 times 8 plus negative 19 times 6. So we're looking at 90 plus 24 minus 114. That is, in fact, equal to 0, verifying that this is orthogonal to the vector U. We'll repeat the procedure. 18, 3, negative 19. We're going to dot that with 3, 1, 3. So we'll get 18 times 3 plus 3 times 1 plus negative 19 times 3. In fact, you could factor 3 out of all of these. We'd have 18 plus 1 minus 19, or we could just multiply and get 54 plus 3 minus 57. In either case, we get 0, verifying that the cross product is orthogonal to the vector V as well. This works every time you take a cross product properly.